Hello students, welcome to online classes. So today we will be discussing our equivalence class. Okay. So let us try to understand with the help of an example. Okay. So R equal to a comma b such that a minus b is divisible by 3 where a comma b belongs to natural number. This is obviously will be an equivalence relation. You can check whether this is an equivalence relation or not. Okay. So now equivalence class of 1, this is denoted by 1. Okay. This is nothing but the set of a comma b such that a minus b is divisible by 3. Okay. Now when we try to find out the equivalence class of some element, then always you replace b with that element. Here it is 1 given, so we will replace by 1. So here it is replaced by 1. Okay. So this we can say a such that value of a, we have to find out a equal to thrice of k. Why a equal to thrice of k? Why a equal to thrice of k? Because we know the numbers which are divisible by 3 are all multiples of 3. So value of, that is why this is 3k form. Okay, so this equal to, we can say a such that a equal to 1 plus 3k. Okay, now what are the elements, what are the value of a we can take. Now see, if I put k equal to 0, then 3 plus 1 is 4. Is 4 belongs to natural number? Yes. Then 4 will come. Okay, 4 will come. Put the value of k equal to 0. And what is the value? 3 into 0 is 0. So a equal to 1. 1 is belongs to natural number, so it will come. Okay. Next, if I put k equal to 2, then 3 to the 6. 6 plus 1 is 7. So it will come. Then if I put k equal to 3, 9 plus 1 is 10. And so on. This way it will come. What I am trying to say is that equivalence class of which element we are finding, it is always replaced by b. Okay, and this is nothing but your value of a, which is where a minus 1 equal to 3k, because this a minus 1 number is divisible by 3. Now a such that a equal to 1 plus 3k. Now value of k can be anything. You have to remember a must be belongs to natural number. Now if I put k equal to suppose minus 1, then what is the value? 1 minus 3, answer will be minus 2. Is minus 2 belongs to the natural number? No. So this will not come on equivalence class of 1. Okay. Now let us try another example. Suppose if I try to find equivalence class of 2. Suppose. So আমরা কি জানি যে ইকুইভ্যালেন্স ক্লাস বাহির করার সময় আমরা কি করি সব সময় যে অর্ডার পেয়ারটা নেব তার সেকেন্ড এলিমেন্ট মানে b এর জায়গায় আমরা এই নাম্বারটা বসাবো। ঠিক আছে, তাহলে কি হবে a, 2 such that a minus 2 is divisible by 3. Meaning is that value of, what are the values of a such that this number a minus 2 equal to divisible by 3 means again thrice k we can say. Okay, now value of a such that a equal to 2 plus 3k. Now you can put the values of k. If I put k equal to 0, then 2 plus 3 into 0 is 0. So value of a is 2. And if I put k equal to 1, 3 into 1 is 3 plus 2 is 5. Then 3 to the 6. 6 plus 2 is 8. Then if I put 3 k equal to suppose 3 is a 9 plus 2 is 11. And if I put k equal to 4, then 3 4 is a 12 plus 2 is 14. All elements will come. Okay, so equivalence class এর মানে কি, যে এলিমেন্টের ইকুইভ্যালেন্স ক্লাসটা আমরা বাহির করতেছি, ঠিক আছে, এই এলিমেন্টটা কার জায়গায় রিপ্লেস করব? b এর জায়গায়। ঠিক আছে, ইকুইভ্যালেন্স ক্লাস ইজ নাথিং বাট ভ্যালু অফ a such that a comma b belongs to the relation. But a comma b means what? আমরা যে এলিমেন্টের ইকুইভ্যালেন্স ক্লাস বাহির করব বিটাকে রিপ্লেস করব ওকে সো ট্রাই টু আন্ডারস্ট্যান্ড হাউ দে উইল হ্যাপেন সি 1 this is the value of 1 so value of 1 minus 1 is divisible by 3 then next 4 minus 1 is divisible by 3 is divisible by 3 divisible by 3 7 minus 1 is also divisible by 3 10 minus 1 is also divisible by 3 for that relation see 2 for that relation 2 minus 2 is divisible by 3 for that equivalence class then 5 minus 2 is divisible by 3 8 minus 2 is divisible by 3 then 11 minus 2 is also divisible by 3 okay then 14 minus 2 is also divisible by 3 okay so what we have seen equivalence class এর মানে কি ঠিক আছে equivalence class এর মানে কি আমরা b এলিমেন্ট a কে এর ভ্যালু ফাইন্ড আউট করি b এলিমেন্টটাকে রিপ্লেস করে okay so next example r is a relation a comma b such that a minus b is divisible by 2 it is also in natural number set of natural number okay now let us if I find equivalence class of 0 under this relation okay so what is the definition I'm directly writing we have to replace b by 0 so such that our relation is a minus 0 is divisible by 2 okay now value of a such that a minus 0 is or 2k where k any integer k value of k may be anything okay so what is a such that a equal to twice k so what are the values will come is if I put k equal to 0 then 2 into 0 is 0 a but a belongs to natural number is 0 is a natural number no so 0 will not come so if I put k equal to 1 then what is the value 2 into 1 is 2 a is equal to 2 so is a belongs to natural number yes 2 then 4 then 6 then 8 then 10 and so on and this we know this is the even numbers all even numbers okay then let us try to find the equivalence class of 1 what is equivalence class of 1 so we know a comma 1 such that a minus 1 we have to replace value of b by 1 আমরা যেটার ইকুইভ্যালেন্স ক্লাস বাহির করব -1 is divisible by 2 okay so see value of a such that a minus 1 divisible by 2 means multiple of 2 that means we can say 2k so a such that a equal to 1 plus 2k now what are the possible value 2k plus 1 this is the form of which type of numbers even numbers or odd numbers obviously or you can put k equal to 0 then value of 1 a belongs to natural number of k if I put k equal to minus 1 then 1 minus 2k 1 minus 2 is minus 1 it will not come because minus 1 is does not belongs to natural number so next will become 3 5 7 you put the values of k 0 1 2 3 4 negative we cannot put because if we put negative k value of k is negative then a value of a is also negative and negative numbers are not in natural numbers okay so these are the elements now we can check also see 2 we know 2 minus 0 is divisible by 2 4 minus 0 is divisible by 2 then 6 minus 0 is also divisible by 2 8 minus 0 is also divisible by 2 okay then 1 minus 1 is also because 0 is divisible by 2 then 3 minus 1 is divisible by 2 5 minus 1 is divisible by 2 6 7 minus 1 is divisible by 2 okay so equivalence class এর মানেটা কি যে equivalence class আমরা যে এলিমেন্টের বাহির করব তাকে আমরা সেকেন্ড এলিমেন্ট মানে b এর ভ্যালু মানবো ঠিক আছে তাকে b এর ভ্যালু মানে যা আমরা যেটা a এর ভ্যালু পাবো that is called your equivalence class of that particular given element ঠিক so let us see another example r equal to set of ordered pair a comma b a minus b is divisible by 2 where a comma b belongs to z now the set has changed okay now let us try to find the equivalence class of 0 equivalence class of 0 is denoted by this okay bracket 0 What is the value? A such that you have to replace B by that element. A minus 0 is divisible by 2. That means A such that A equal to twice K. Okay. Now what are the possible values will come? Now you can take negative also. If I put K equal to 0, then what is the value? A equal to 2 into 0. A belongs to Z, integer. So it will come. And next, if I put K equal to 1, then 2, then 4, then 6, then 8, and so on. Okay. Now I can put negative also, because if I put K equal to minus 1, then its value is minus 2. It will come because A belongs to Z. Okay. Then next thing, if I put K equal to 2, then it is minus 4. Okay. So this set can be written as 0, plus minus 2, plus minus 4, plus minus 6, plus minus 8. Okay. So, so let us try to find equivalence class of 1 also. What is the equivalence class of 1? A such that we have to replace D by 1 is divisible by 2. This equal to, you can say A such that A equal to what? Sorry, A minus 1 equal to twice K. This equal to A such that A equal to 1 plus twice K. Okay. So what are the possible value? 1 plus twice K. Which type of form is? This is all odd numbers. Okay. Now if I put K equal to minus 1, if I put in earlier relation, we cannot put minus 1 because value of A then will be negative, and we cannot take the negative value of A because in that relation A, B both belongs to the natural number. Now A, B belongs to Z, all integers. Okay. So that is why. So if I put K equal to minus 1, then 1 minus 2, value of A is 1, minus 1. Okay. Then if I put value K, if I put K is equal to 0, then value of this is 1. Okay. Then if I put K equal to 2, K equal to 1, then 1 plus 2 is 3, then 5, and so on. Okay. Now if I put K equal to minus 2, 2 to the 4, minus 4, 1 minus 4 is minus 3, and so on. So this set can be written as plus minus 1, plus minus 3, plus minus 5, plus minus 7, and so on. Meaning is that if I change the set, then our equivalence class will also change. If I change the equivalence relation also, then our equivalence class will change. Okay. Now if I find equivalence class of 2, then that is value of A such that A minus 2 is divisible by 2. That means A such that A minus 2 equal to how much? Twice K. That means A such that A equal to 2 plus twice K. Now for try to find. If I put K equal to 0, value of K does not have any restriction. Value of K may be anything, but you have to remember that A should come from the integer. Okay. So if I put K equal to 0, then value is 2. Okay. Then if I put K equal to 1, then 2 plus 2 is 4. If I put K equal to 2, 2 is 4 plus 2 is 6, and so on. Okay. If I put K equal to minus 1, then value will be 0. Then if I put K equal to minus 2, 2 to the 4. So 2 minus 4 gives you minus 2. So what? So you will find that what are the elements will come? 0, plus minus 2, plus minus 4, plus minus 6, and so on. So what we have got? Equivalence class of 0 is all even numbers containing 0. Equivalence class of all 1 is all odd numbers. Then equivalence class of 2 is again we are getting equivalence class of 0. So these are the property equivalence class have. You can check also each element related to one another. We can say 0 and 2 are related. Why? 2 minus 0 is divisible by 2. Okay. Or we can say 0 minus 2 is also related to one another. Why? Because 0 means 2 minus 2 minus 0 is also divisible by 2. You can check also 2 and 4. 2 and 4 are they related? 2 and 4. Let us check. If I take if they are related, then their difference must be divisible by 2. So what is the answer? Minus 2 it is divisible by 2. Can I say 4 and 2 related? Yes, obviously. 4 minus 2 is 2, which is also divisible by 2. Okay, so each element will be related to one another. Second, what we have got, this equivalence class of 0 and equivalence class of 1 is empty, means they don't have any common element. Okay, and equivalence class of 0 and equivalence class of 2 are equal. So in general, in a relation, if we find any equivalence class, suppose A and B, any element, then either they are equal or they are distinct, means they don't have any common element. Okay, means their intersection is empty. And third property we have seen, equivalence class of 0 and equivalence class of 1 gives you the set entire set of integers. Why? See, equivalence class 0 contain all even numbers containing 0, and equivalence class 1 contain all odd numbers. So if we take their union, then it's give you set of integers. Okay, so in this type of situation, if 2, 3, 4, 5, how many equivalence classes are there? If they are distinct and this distinct equivalence class satisfies this property, then this is called a partition of Z. Partition of Z. Z means what? Partition of the set on which the equivalence relation is defined. যে সেটের মধ্যে আমরা ইকুইভ্যালেন্স ক্লাসটা ডিফাইন করব, ঠিক আছে, এই সেটকে আমরা কি করব, আমাদের ইকুইভ্যালেন্স ক্লাসে পার্টিশন করব। ওকে, আন্ডারস্টুড? নেক্সট এক্সাম্পল, let m greater than 1 be a fixed positive integer r equal to a, b such that a minus b is divisible by m where a, b belongs to z. ঠিক আছে, means what we have discussed the examples, this is the standard example. Okay, so if we under this will be an equivalence relation, you check whether this will be an equivalence relation or not. Okay, if we find equivalence class of 0 and equivalence class of 1, equivalence class of 2 up to equivalence class of m minus 1, you will find that they will be all are distinct. Okay, and equivalence class of m equivalence class of m plus 1, they will be all are equal. Okay, so under this equivalence relation, how many partition of Z are there? How many? 1, 2, 3, 4, m minus 1. Okay, so if I take below specific below m equal to 2, then our that one relation are coming. Okay, means equivalence class of 0 and equivalence class of 1, these two distinct classes are there. If I put m equal to 3, then equivalence class of 0, equivalence class of 1, then equivalence class of 2, because up to m minus 1. Okay, we will start from 0 and we have to go to up to m minus 1. Okay, so you try to remember this. Under this equivalence relation, value of m may be anything, 4, 5, 6, 7 also. So question will be asked that how many number of partition of Z. Okay, so if you remember this thing, you can easily answer the question. Textbook, you try to solve the examples from your textbook.